our world and beyond. Space, in partnership with the European Space Agency.
The universe, millions of galaxies, each of which contains millions of stars, some of which have their own system. We're only just starting to get to know our own, which revolves around the Sun, but the main question remains unanswered.
The big search is the search for life in the universe, or to understand our own role, our own place in the universe.
It's like this major question which scientists have always been preoccupied with. What are the mechanisms that help explain how the planets in our solar system function?
Some of the answers can be found in the study of exoplanets, or planets located outside our solar system. In order to better understand these exoplanets, let's speak to one of the men who discovered the very first one, Swiss astrophysicist Michel Mayor from Geneva Observatory.
The first instrument used to study these planets is called Elodie. It's installed on an old telescope at the Observatory of Haute-Provence. In fact, the telescope is less than 2 meters long, so compared to today's instruments, it's relatively small.
The existence of exoplanets had long been suspected, but definite proof wasn't found until 1995. That was when Michel Mayor and his colleague Didier Queloz discovered a planet orbiting around a faraway star. They called it 51 Pegasi b.
It's star number 51 in the Pegasus constellation. We thought it would be funnier to choose that name rather than something like HD 214. So what's special about it, apart from the fact that it was the first one we discovered? Well, it's the prototype of a family called the hot Jupiters. They're planets whose mass is close to that of Jupiter, but which orbit the star for extremely short periods. In this particular case, 4.2 days. It orbits the star in just over 4 days. Of course, we don't have planets like that in the solar system.
Has the solar system as we know it always been the same? Maybe some of the answers can be found by taking a look at the 500 exoplanets discovered so far.
We were quite sure there were other planetary systems, but we thought they were all built along the same model as the solar system, with small rocky planets in the middle and gaseous planets on the periphery. These 500 exoplanets have shown a much richer world, with giant planets at the center and small rocky planets or small masses swarming around the star. Resonance systems, larger planets, and especially planets with orbits that are more elongated, things you don't find in the solar system.
Not only do exoplanets open up new horizons in the study of the universe, they also open the way for research into the origins of life as we know it, and other possible forms of life which we may not yet have encountered.
In order to have life, it can only exist on a planetary surface or very close to a planetary surface. And it has to be the right sort of planetary surface also, so something very similar to our own Earth. We have been looking for these kind of planets around other stars now for 15 years since the first one was discovered. And so far we haven't found anything that really looks like what we have in our solar system. We are continuing, but it's a mystery. We are looking for something that may be relatively rare or could be very common.
In fact, one cannot physically see exoplanets as our instruments are not efficient enough. The technique developed by Michel Mayor and his team allows them to spot the tiniest deviation in the axis of a star when a planet passes by it. The frequency of this deviation allows them to determine the planet's orbit.
We knew how to spot them. There were many of them. And we had Doppler spectroscopy, which we used, and which led to most of our discoveries. Otherwise, there's also the technique whereby you observe the planet as it crosses a star. It's called the planetary transit system.
The transit method is one of the most commonly used. If a planet crosses in front of its parent star's disk, then the observed brightness of the star drops. That's the job of detection satellites such as Corot, launched in 2006 in a joint mission by the French and the European space agencies. Corot detects extrasolar planets by observing the periodic micro-eclipses that occur when these bodies transit in front of their parent star.
When you do a detection like we do with Corot, where the planet is passing in front of the star, you get the geometrical size of the planet expressed in terms of how big the star is. Then you need to observe the star and find out how big the star actually is. You do that with ground-based telescopes.
The mission of these large telescopes is to determine the physical characteristics of a star in order to work out the characteristics of the planet or planets that orbit around it. It's harder than finding a needle in a haystack.
It is extremely difficult. I mean, comparing it to seeing a coin on the moon, it would be easier to do that. The planets are incredibly far away. They are very close to their own star. The light of that star drenches the light from the planet. So it's more like finding this coin in orbit around the planet Jupiter in the solar system.
Let's imagine, for instance, trying to spot a coin orbiting Jupiter. The biggest planet in the solar system, Jupiter is 11 times the size of the Earth and lies 800 million kilometers away. Spotting one of its orbits is a huge technological challenge, to say the least.
What's amazing, 15 years after discovering the first exoplanet, is to see how much this field has developed. The wealth of ideas, both in theory to try to understand how the system is made, and in practice, in order to actually find them. And I think that everything we're observing now will help us better understand our own solar system.
15 years of discoveries and innovative technology. Exoplanetary science is young, but has already gone far and keeps growing every day.
We are starting to find the technology that we want to. We will work in a step-by-step approach until one day when we actually build the space mission or the combination of space and ground-based facilities that actually can find the signatures of life on an exoplanet.
Does extraterrestrial life exist on one of these exoplanets, and if so, in what shape? The answer perhaps is just around the corner, but to go there and meet this other form of life could be a different challenge. The closest lies no less than 10 light years away from us.